Hello everybody, here's another example about related rates. There is a forest fire in the shape of a circle. And this forest fire is expanding so that the area of this fire, for example, expanding at a rate of, say, 100 square kilometer per week. Here is the question: how fast is the radius of this circle expanding at the point, at the moment when the radius equals, for example, say 50 kilometers. So here's what this problem is talking about. So there is a circular forest fire and it is expanding in all directions, but it stays circle, so it's expanding, just becoming a bigger circle. And now let's say by observation of this fire, so they can determine exactly how fast the area, this is the burnt area here. So how fast the burnt area is expanding? It is expanding at this rate, at the rate of 100 square kilometer per week. And then the question is how fast the radius is expanding. And this makes perfect sense to determine, because let's say that there is some kind of, I don't know, town or city, so we want to know how fast it goes toward this town or city. So this kind of question is extremely important, so how to answer it. Now again, this is all about that dynamics, about the related rates, and now we will solve this problem in the same way like we solved other problems of related rates. So once again, the solution is divided into steps. Solution is a pretty long procedure, so it's divided into steps. So step 1 will be determine the two variables, the two quantities. So the first quantity is the one whose rate of change is given, and this is the area, because this is the area of the fire expanding at this rate. So part A, the quantity whose rate of change is known, well, it actually doesn't matter which one goes first. Let's say let's go first with the quantity whose rate of change is known. Its area. Because it says that the area changes at the rate of 100 square kilometer per week. So area is denoted by A. Again, we think of it as a function, actually it's a function of time. And then the rate is the derivative. Rate of change is the derivative. And it's given, it's equal to 100 square kilometer per week. 100 kilometers square per week. And then the second quantity is the quantity change is asked for. And this quantity is typically mentioned in the question after the words how fast. And I raised them already, but the question was how fast the radius of the fire was increasing. So that's the radius. Again, the radius is denoted by r, or since it is changing with time, it's function of time, so it's correct also to denote it r of t. And the rate of change of the radius is the same as the derivative, r prime, and this is the unknown. This is what they asked for. So these are the two quantities, and that is step 1 of the solution. Now step 2 is the equation relating the two quantities. In this context, it will be relating A and area and the radius. And now, since this fire has the shape of a circle, so we're talking about area of a circle, and the relevant formula is A equals pi r squared. That was step 2. Now step 3 should be left-hand side derivative equals right-hand side derivative. Step 3, we look at the equation that we obtained in step 2, so left-hand side of this equation is A, right-hand side is pi r squared. So left-hand side is A, therefore left-hand side derivative is A prime. This is my notation. Right-hand side of the equation is pi r squared. Therefore, right-hand side derivative is pi times 2r, and then we need to multiply times the derivative of r, because r is a function. So right-hand side derivative is pi times 2r times r prime. Again, to obtain this, we need to apply chain rule, because r is a function, and by the chain rule, we do derivative of this expression like normal way, which means it's 2r, and then we need to multiply times the derivative of the interior part, which is r prime. And since left-hand side derivative equals the right-hand side derivative, so we get a prime equals pi times 2r and times r prime. And now this is the second, the new equation that involves not only the quantities but their derivatives as well. And from here we should be able to find what is asked for. Like the part that we need to find is r prime, so this is the unknown. So everything else in this equation should be known. And in fact it is, like a prime is given to be 100, pi is just a number, pi 3.14, 2 is also a number, r is given as well. So the question was, find the rate of change of radius at the moment when the radius equals 50. So it's 50 kilometers. And so we know everything. So we have 100 equals pi times 2r times 50 and times r prime. Therefore r prime equals 100 divided pi times 2, it's not 2r, it's 2 times 50, because r is already equal to 50. So 2 times 50, and that's pretty much it. 2 times 50 is 100, so we can actually cancel them. And so we get 1 over pi. And, well, pi is approximately 3, so 1 over pi is approximately 1/3, but we can make it more precise on the calculator. On the calculator, it's 0.3183. 0.3183. So this is the rate at which the radius is increasing. And now, of course, we also need to know the unit. And as always, we can calculate. We calculate the unit just by common sense. We say it's rate of change of the radius. Since radius measured in kilometers in this problem, and the time measured in weeks, so it's kilometer per week. Or otherwise, we can do it precisely by looking at all the numbers involved in the calculation and their units. Like 100 is a rate of change of the area, and it's measured in kilometers squared per week. Pi and 2 don't have any unit, but 50 has a unit. 50 is the radius, it's just kilometers. And now kilometer squared and kilometer constants, and we end up with kilometer per week. So it's kilometer per week. So that's the unit.